In our experiment this week, we'll be trying to find the percent of sulfate in a sample. And to do that, really, we just need to measure a sample mass and then analyze that sample for sulfate content in grams. So we'll take the sample and we'll place it in a beaker. And it'll contain a certain amount of metal sulfate unknown inside the mixture. That sulfate sample then will dissolve, and then we'll add barium chloride to that. And what you'll see form in the solution is the solid precipitate barium sulfate. Now our goal then is to isolate this barium sulfate from the solution, and we use filtration for that process. We'll be using a funnel and essentially pouring all this solution through the funnel with a filter paper in it. So I'm going to draw a little filter paper on the inside like this. Okay. Now, the first part of the filtration is fairly straightforward. You just need to pour most of the liquid through, and then we'll wash the solid to try to remove any of the excess barium chloride. Now, once we've done that, we take the sample and we fold it up into a little triangle, and we stuff it inside a crucible. And that crucible will get heated with the filter paper. So this represents the crucible in the heat. It gets heated with the filter paper on the inside and the little bit of gray sample here, right? That's our product that we're trying to collect. Now, barium sulfate won't decompose in the heat, but the paper will. And eventually what ends up happening is all the paper will burn away in the crucible, and then we can allow this sample to cool and then record the mass of barium sulfate. So to find the mass of sulfate from the sample, we're going to do the following conversion. So I'll do mass of barium sulfate, and then we'll convert that into moles of barium sulfate. And that can be converted into moles of sulfate. And again, using a formula ratio of 1 mole of sulfate for every barium sulfate, and then we can convert this to grams of sulfate. So we'll take the mass of sulfate, divide that by the original sample mass, and we should be able to calculate the percent sulfate from that data. So this is actually a 2-day lab. It takes about 1 day to form and filter the precipitate from the solution. And then it's pretty busy because you're going to be dealing with 2 samples at the same time. Make sure you watch the videos on how to do some of the different parts. It should help you work a little bit more efficiently. And then on the second day, that's when you'll be ashing or removing the filter paper from the sample in the crucible. And that day tends not to be as busy because all you have to do is really heat the sample for each sample for about 20 to 25 minutes, and then wait for them to cool and then heat them again. So in all, it takes maybe an hour and a half, but it's a pretty relaxed hour and a half. But that first day is going to be pretty busy. So I've made some comments on how you should prepare your notebook. You don't really need to prep the day 2 material for day 1 before day 1 is completed. So go ahead and focus on day 1 for the first part. Make sure you write all the steps of the procedure into your notebook. And your data tables need to take into account you're doing 2 trials. So you're going to have a mass of sample, which you're going to do by difference. And so you'll need 2 lines for the mass of sample, and then 1 for the filter paper with the sample, 1 for the filter paper with any residue. And then you'll need 1 line for the actual mass, which is the difference of those 2 values. You're going to need the mass of the empty crucible after heating. And you actually have to heat the crucible a couple of times to make sure the mass is stable. And you'll do the same thing with the sample after you ash it. So you need to leave 3, maybe 4 lines for mass. You don't actually weigh it before you heat it, but you weigh it after you heat it, and then you'll let it cool, heat it again, and then weigh it again, and then you'll You'll be able to determine whether or not your mass was stable. There's a list of items that you have to get, but because you have unknowns and you're doing two samples at the same time, I'm going to encourage you to make sure you write some sort of identifier on the beakers, like 1 and 2 with your initials. So mine would be KTK1, KTK2. I would have that on 2 beakers, and then I would put a piece of tape on each of my stirring rods with the same designations. And if you want, you can do A and B as well. There are several hazards in this lab. Barium ions are fairly toxic towards your liver. So if you get exposed to it, we need to take care of that right away. You'll need to wash any affected areas with soap and water, and if you get it in your eyes, you'll have to rinse it for 15 minutes. So the same is true for hydrochloric acid. Now, silver nitrate can cause a chemical burn, but usually it's a stain. And if it's on your skin, it's not that big a deal. You'll get a stain on your skin. It's caused by the silver reacting with light from the sun, UV light. But if you get it on your eye, it could actually cause a stain on the white of your eye. So you do need to be careful. Make sure you wear goggles and a lab coat all the time. Okay, so I'm going to sort of go over this very quickly, but I'm not going to spend a lot of time on all the details. You can read the details. The steps are actually what you see right after the bulleted number points, and these are sort of some background information that helps you understand why you're doing that step. These parts don't have to be in your notebook. So you're going to get a 1 gram of sample about in a vial, and you're going to take about 0.4 grams. Okay, so this is a range that's fairly acceptable, but try to get as close to 0.4 grams as you can of known, unknown, and you'll weigh it by difference, and you'll add it to a 400 milliliter beaker. And then what you'll do is you'll add to each of those beakers. So you'll do this twice, and in fact you can do both of your unknowns at the same time. And then you're going to add 125 milliliters of deionized water to the beaker. So each beaker gets 125 milliliters of water. Normally in the procedure, this is heated, but I figured since this was sort of an introductory lab to this kind of technique, I didn't want you really pouring a lot of boiling hot water in this experiment. It's a little bit difficult to do. So we'll add the deionized water. And then you'll walk over to the hood and you'll add hydrochloric acid, about 2 mils. And then you'll heat the beaker to above 90 degrees, near boiling. Now, if you've ever boiled water in a pot, you know what it looks like when it boils. It's bubbling, right? But right before it boils, you know how it's very steamy. That's what you need to do. And you'll have a thermometer that you could check the temperature with. Do not use the thermometer as a stirring rod, because if you break it, then you have to remove that. You have to redo the sample because all the liquid inside the thermometer will go into your sample. Okay, so there's a note here, and this is an important note apparently. I didn't mean to double type that. You should have the barium chloride ready to add before you start heating. See, in step 5, what you're going to be doing is adding 15 mils of barium chloride while it's nearly boiling. So you're going to grab whatever you've put the 15 mils of barium chloride in and pour that rapidly into your sample while you're stirring it and heating it. Okay, and then you'll heat it near boiling for a couple of minutes, and then you need to remove the heat. You stop the stirring and the heating. Now, when you remove the heat, it will sometimes continue to boil because the heat that's being transferred from the iron ring that it's sitting on will transfer into the beaker and continue boiling it. You need to stir it until that stops. Okay. Now, you let that settle, and you add a few drops of barium chloride to the solution. And if you see more solid form, what you need to do is add 2 more mils of the 0.25 molar barium chloride. Now, that'll let us know whether or not you have completed the reaction. If precipitate forms, a lot of precipitate forms especially, then we know not all the sulfate reacted. And the sulfate is the limiting reactant. So make sure that you don't see any precipitate after this happens, or if it does, right, then you need to go back and heat it for a couple of minutes. right? And then recheck for completeness. So really you're going to repeat step 6 until the second step comes out clear. Now, one of the things that students have trouble with is that when you add two liquids together of differing densities, you'll see waviness in the solution. That's not the formation of more precipitate. That's just from the different indexes of fraction of the solutions because of their temperatures and their compositions. And so don't worry about waviness, but make sure it's not cloudy. Okay. Now, this last part is digesting the precipitate. And really all that means is just covering it with a watch glass and letting it cool for about 90 minutes. Normally this period's a little bit longer, but since we're running 2 samples, I thought it would be easier to run them for about 90 minutes. Typically students doing this procedure will do 4 samples, so hopefully you'll be able to handle doing 2 samples in the same amount of time. Now, what's happening when you're allowing that sample to cool is that the barium chloride so when you pour this, let me back up for a second. When you add the barium chloride to the solution, some barium chloride gets trapped inside the barium sulfate. And so by letting the sample digest or cool slowly, what ends up happening is the barium chloride gets dissolved out of the barium sulfate crystals. And the other thing that happens is that the crystals will continue to grow in size. And so when you have larger crystals, they tend to filter better. So make sure you cover this with a watch glass, because that slows the cooling rate and allows that digestion process to take place over a longer period of time. So a lot of what's in this section, I've recorded short videos to show you how to do those things. It shows you how to heat approximately 400 milliliters of water by setting it up on iron rings. That's mostly a safety precaution. It shows the setup for the 2 funnels and how to fold the filter paper that you'll use for filtering the solutions in the funnels. And it also shows you how to deal with the sample once you've done the filtering. So what I'll talk about here is a little bit about what you're doing in the actual filtering process. So the first step of the filtering is just to get most of the liquid through the funnel. Now the liquid contains all the excess barium chloride, and so your goal is mainly to pour all of that through so that it's no longer in contact with your sample. And then what you'll do is add hot water to your sample once you've removed most of the liquid from it. In fact, try to get rid of all of it. If some of the solid goes into the funnels, it's not a big deal. You'll eventually put all of the solid into the funnel. So what you'll do is you'll add 20 to 30 milliliters of hot deionized water. That's the water that you've prepared up here. And then swirl it around, and this will be in your beaker. So I want to make sure that you understand what you're trying to do here. The solid at the bottom is the barium sulfate. All the impurities are in the liquid. So by pouring all of this off away from the solid, that gives you a better opportunity for washing the solid that remains. So pouring most of it off helps a lot. And then you'll add 20 to 30 milliliters of hot water through here. And then you'll take that supernatant, the liquid above the solid, and you'll pour that through. And then you'll repeat this process at least 2 times. So once here, and then it says repeat this, so that's twice. And then finally what you'll do is you'll add, again, 20 to 30 milliliters of hot water, and then try to transfer all the solid into the funnel. You'll just keep doing that, and you may have to use a squirt bottle to squirt some of the solid out of the inside and get that all into the funnel. We call that quantitative transfer. It just means get all of it. Sometimes, in fact, most of the times, on the sides of the beaker, right, you're going to have solid barium sulfate that decided to precipitate on the sides. So we use like a little, it's like a chemistry spatula. It's been called a rubber policeman for years. I don't know where it got that name from. But you use one of those, a little spatula kind of thing, to swipe off the sides and get the solid to all go into the liquid, and then you'll pour that liquid into your funnel. Now, once the liquid is all in the funnel, let it drain. Okay, so the precipitate that's in the funnel, you'll let all the liquid drain, and then you'll add 10 mils of the hot deionized water. And you can just use a pipette for that and squirt it around the top. So the liquid, the 10 mils, will go around the top, and that'll wash all the impurities down away from the top of the filter paper and try to wash it out. You'll do that process twice. And then on a third try, you'll add 5 mils of water. And each time, make sure you let it drain as much as you can possibly stand to wait. Okay, and then you'll collect the filtrate. That's the liquid. The supernatant, when it goes through the filter paper, gets a new name. It's called the filtrate. And you'll add to the filtrate in a test tube silver nitrate. And if you still have a lot of chloride present, it'll turn very cloudy. If it turns lightly cloudy, we can probably go on from here and go to the ashing step. And again, you'll be running 2 samples at the same time. So while there is a lot of waiting in here, that waiting time could be mostly used for working on the other sample. If you find yourself waiting a lot, what you can do is go ahead and set up the preparation of the crucible, which says you may do this on the first day, so you want to put these steps into your notebook. Okay, most of this process is shown in videos, so they're inserted in the procedure in the assignment. It shows you how to set the crucible on a ring stand, and then it shows you how to heat it, right? That crucible will sit on a ring stand on a clay triangle, or a wire triangle in this case, and we'll heat it to redness. And this, we're going to try to be removing most of the impurities that may be on the glass. The primary impurity is actually water that adheres to the glass, but there could be other things. So you'll heat it to redness, and then you'll also heat the crucible cover, and then you'll let them cool for 5 minutes, okay? And we're going to try to either put them in a desiccator, or if we don't have the desiccators, we'll set them on wire mesh on the counter. It has an actual insulated lining on it, and you'll be able to cool the crucible there. And then you'll weigh that crucible once it's returned near room temperature. And record its mass to the closest 0.1 milligrams. So on our balances, that's 0.000, and it's this digit here. Record whatever, all the way down to that digit. And try not to touch the crucibles with your fingers. Use the crucible tongs. Even having those gloves on it, they pick up a lot of residue, and that residue will add a significant amount of mass to that crucible. So you'll weigh the crucible, and then you'll repeat these steps of heating, getting it red hot, allowing it to cool, and weighing it again. So there is some waiting time in here. So if you sort of put that in with your filtering, it usually works out pretty good. The other thing to make note of, and this is an important one, use the same balance through the whole procedure. Now, the other thing is to make sure the balance is clean before you use it, because if there's stuff on there and you stick it on the balance, it'll get stuck on your crucible, and then the coming to constant mass step takes forever, okay? So just make sure it's really clean before you put the crucibles on there. Now, once you've done that, then again, you'll record that last mass in your notebook, and then you need to set the crucibles aside. We'll have a place for you to put them so that you'll have them for yourself on day 2. So we'll probably have you put them in beakers with your name on it, and we'll call them A and B, or 1 and 2, something like that. So on day 2 of this experiment is when you'll ash the samples. Now, you'll know that you filtered it on day 1, and it's in a filter paper. What we'll have you do if you've already heated your crucibles is we'll have you stick them inside your crucible so you can keep track of which sample is in which crucible. Now, if you haven't heated your crucibles, we may still have you do that, but we need to make sure, you need to make sure actually that you properly label whatever container you put that filter paper in after day 1. Okay, so whatever comes out of here. Right. There's a video that shows you how to fold that and put that in a crucible, so make sure you watch that video so that you don't mess it up. Now, the ashing of the sample is pretty straightforward, and again, that's covered in videos. You essentially heat it until the sample, the paper actually in the sample, burns away. Again, watch the videos and I'll teach you how to do that. And then again, at the end, we're going to heat the sample until it comes to constant mass. The sample should be completely white, but as you'll see in the video, sometimes there's a little bit of gray residue that's left over from the filter paper. So even though it's supposed to be ashless, occasionally there's a small amount of material that we see, which could actually come from fingerprints or other things that have come in contact with the paper. Okay, so we're going to let the crucibles, again, cool for 5 minutes, weigh them, record the mass to the nearest 0.1 milligram. The tolerance for constant mass is 4 milligrams. So on your repeat of this process, just like you did up here, right, you're going to go ahead and check to make sure it's within 4 milligrams. We give a little bit more tolerance because you have a sample in there, and the ashing process can really go slow towards the end. So that should get you through the procedure. If you have any questions, feel free to contact me.